Okay guys, so what I'm going to do for you is I am going to go through the second half of your Unit 1 review. Okay, so I'm hoping that you were able to finish the first part, this Unit Test A. Okay, so scroll down to the one that says the Unit Test B or C right here. Okay, and we're going to go through it. It might be smart of you to take notes or remember that you can use a cheat sheet on this test. So if you want to have a separate sheet of paper out to add a little extra something on it, hopefully you already have one made. So have that ready. Okay, so question number 1. So question 1 says we have angle 1, which is going to be x. So this is that angle, and if I have angle 5, that's also x. So basically what it's saying is these two angles are congruent. They're both equal to x. So it says, which postulate or theorem can we use to prove that the two lines are parallel? Okay, so if you compare these two angles, they are corresponding angles. So it would be by the corresponding angle theorem. Okay. For question number 2, so now we have angle 3, so we're going to let angle 3 be x, and we're going to have angle 6 be 180 minus x. Okay, so which theorem or postulate can we use to prove that these two, or that B and C, or excuse me, C and B are actual parallel? Okay, so you can see, hopefully you look at those and say, okay, those are supplementary. So they are same side interiors. So that would be by the same side interior angle theorem. Okay. All right, so now 3 says to state the properties for the side angles and diagonals of the parallelogram. Of a parallelogram, excuse me. So things that we know about parallelograms, okay? We could make a nice little list. So you know on a parallelogram that opposite sides are parallel. Okay, we also know that opposite sides, because of that, are congruent, so they have the equal length, congruent. Okay, we also know that the opposite angles are also congruent. Okay, and we also know stuff about their diagonals. Okay, so if you think about a parallelogram, just draw a generic diagram. The diagonals, okay, now don't assume I ever draw anything to scale, but you can kind of tell here that the diagonals are going to bisect each other. So meaning that if I have, if I have this one, so this length from here to here is the same length as from here to here, and on its opposite diagonal, okay, this is going to bisect that one. Okay, so we can say diagonals bisect each other. Okay. We also know there is one more thing we can remember or can say, the angles. So the angles that are corresponding, so if you kind of say next to angles that are corresponding, what is the relationship between corresponding angles? Corresponding angles are supplementary. So, okay. I do believe that's all. That sounds pretty good. Okay. Number 4. Okay, so number 4. Now, this is kind of an interesting question. It says the vertices of the quadrilateral, they give us A, B, and C. What are the locations of the fourth? Okay. Now this question has multiple answers. Okay. Depending on how you kind of see this rectangle. So notice that we are supposed to make a rectangle. So I'm going to draw a picture and kind of feel out where I believe that this point would land, and then kind of use the slope, because I know if I'm working with a rectangle that my opposite sides have to be parallel, okay? And also those angles have to be 90-degree angles, okay? They have to be perpendicular. So if I plot my points, I have -5, 3. So there's point A. If I plot B, I go to -1, 6. There's B. And C is at 5, -2. Okay, so you can kind of fill this out. I really feel like my fourth point is going to land right over here. Okay, so you can kind of see this rectangle playing out kind of over here, right about there. Okay, so I'm trying to find this point. So what I'm going to do is I'm going to use my slope to find it. Okay, so I can say if I was going to go from B to C, I know that this other opposite line has to have that same slope. Okay, so for me to get from B to C, I would have to go, let's see, it would be down 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'd have to go down 8, and then I'd have to go to the right 1, 2, 3, 4, 5, 6. Okay, so I need to go down 8 and to the right 6. So I have that same slope from point A. So for A, I'm going to go down 1, 2, 3, 4, 5, 6. So me down here. And then I have to go, 6, 7, 8, excuse me. I have to go down 8 as it says. And then to the right 6. And now I'm going to go to the right 6. So 1, 2, 3, 4, 5, 6. So that point is going to land right there. So that point is 1, and I went down 1, 2, 3, 4, 5. 1, -5. Looks pretty good to me. Okay, so we'll put 1, -5. So using that slope idea to come up with that additional point. So now you can see that this does make a rectangle. We could even test the slopes and make sure. So if this slope is -8, 6, which reduces to -4/3, then the slope from this point up to C should be the reciprocal, the negative reciprocal of this, so it should be up 3/4. So you can see that if I was going to do that, to check it, I could go up 1, 2, 3, and over 4, 1, 2, 3, 4. Okay, so that is a perpendicular angle between those two lines right there. So I know that I'm in the right spot. Okay. All right, off to number 5. Okay, so number 5, it tells us we have this quadrilateral and that lengths B to E is congruent to E to E. So that is a perpendicular bisector. Okay, so it says that EC, from E to C, this length is 10. Okay, and the length from A to C, so notice A to C is the whole length, so 3x minus 5, so the length from all the way over. For what value of x do we make a parallelogram? Okay, so this is going to be that statement of, I know that for a parallelogram to exist, our diagonal lines must perpendicularly bisect each other. So I know that the length from A to, what is that point in the middle, A to E, and the length from E to C have both got to be 10, right? Since they're equivalent, so 10 and 10, so that complete distance is 20. I know that's got to equal my entire length, so that's got to be 3x minus 5. So I can now solve this algebraic equation. So to isolate the x, I'm going to add 5 to both sides. So that makes, 25. Okay, so then I have equals 3x, and I divide by 3, and ooh, that's gross. So x is 25 thirds, and I'm going to leave it as 25 thirds. That is an exact value. I don't have any units, so my x value is 25 thirds. So it says, explain your reasoning. This algebraic step is probably good enough explanation for me. If you wanted to include something like, because the diagonals bisect each other, I know that AE plus EC is equal to AC. Okay. So now question number 6. So 6 is using the same quadrilateral. Is there a type of parallelogram that would ensure that the angle of BEC, so BEC, so that's this angle right here, is an isosceles triangle, or the triangle, oops, excuse me, not angle, triangle. So how could we make sure that this is an isosceles? So for that to be an isosceles triangle, that second side right there, the length from E to C would have to be the same distance. So basically that means that both of the diagonals would have to be the same length. Okay, so for the diagonals to be the same length or to be congruent, what shape would you have to be working with? Okay, so there's two possible shapes. You could be working with a square or a rectangle. So squares and rectangles both have congruent diagonals. Congruent diagonals. Okay. All right, number 7. So there was a couple questions, and I think a lot of people kind of struggled with the question like this on the previous tests. So make sure you pay attention closely to this. So it says, the equation of the 3 lines are shown. What must be true for the 4th line such that it would form a quadrilateral that is not a parallelogram? Okay, so this one says not. So we want to be thinking about parallelograms. Okay, so anytime we should be thinking about parallelograms, we're talking about lines that are parallel. Okay, so for us to be working with any kind of linear equation, you can see all of these lines are linear. Hopefully you remember the form y equals mx plus b. So this is from, I think this is from Algebra 1. The m, the value in front of your x, is your slope. Okay, the b is your y-intercept. Okay, so we could draw these lines and look at it graphically, but I don't think we need to. We're just thinking about parallel lines, and if you remember anything about parallel lines, we got to be working with same slopes. Okay, so I know that the opposite lines have to be parallel. So if I look at this first equation, the slope is the value in front of the x, so the slope would be 5. Okay, the slope for the second equation value is also 5. So those two lines are parallel. The third line, the slope is -1/3. So the 4th line needs to be parallel to this. Okay, so I need a line that has a slope of -1/3 and basically cannot have the same intercept. Otherwise, if I had a +2, we're talking about the same exact line. Okay, so I can really have any answer as long as my slope is -1/3. So I could say plus, I don't know, 10. You can choose whatever y-intercept you'd like. Doesn't matter. You can have a positive, you can have a negative. So key piece on that one is that slope piece. Okay. All right, so question number 8. This question is kind of similar to question number 4. The only difference is now we're working with a different shape. And, well, now we have to take these points and prove what shape we're working with. So I'm going to start by plotting the points because I kind of want to narrow down just visually, do you think I'm working with a rhombus or a rectangle or neither of those? So plotting the points is going to kind of give me a head start. So if I plot the point 1, 2, that's my D. Oops, I better put that over there. D. And then I have 3, 5. And that's E. And then I have 5, 2. So that's F. And G is 3, -1. So I tried to draw that as close to a nice scale as possible. So if I connect these dots, that really looks like all those lengths are the same to me. So I want to prove that this is probably a rhombus. Now it is possible for a rhombus to be a rectangle, technically, because a rectangle just has 90-degree angles and opposite sides are parallel. So for me to disprove the rectangle, I'm going to prove that these two lines, so D to G and G to F, are not right angles. Okay, so I would use their slopes to decide that. So for a rhombus, I have to have all 4 sides are the same. Or the other way to prove the rhombus, which is going to be a faster proof, is to prove that if I do a diagonal, the diagonals are perpendicular. So for a rhombus, I mean, this might be something you write in your notes. My diagonals are perpendicular. So this way I only have to work with 2 lengths instead of finding all 4 lengths of the sides. So you can do all 4 sides if that makes sense to you, but I'm going to do diagonals because that's less work. All right, so to find my my slope, so I'm looking for a slope to prove perpendicular. So remember, perpendicular slopes are negative, so slope is a negative, so like opposite, and then reciprocal, meaning you flip the fraction. Okay, so if I'm going to prove my slope from D to F, okay, so D to F, I'm going to do my change in Y. So if I'm going from D to F, see there, so I'm going to go 2 minus 2, Y2 minus Y1, over X2 minus X1, so 5 minus 1. So 2 minus 2 is 0, 5 minus 1 is 4. This gives me a slope of 0. Okay. So now I need to have a perpendicular. So basically a flipped version of this scenario. So if I go from E to G, I'll do this in green here, E to G. So my change in Y, so -1 minus 5 and 3 minus 3. So I get -6 over 0. So you should know that a slope of 0 is a horizontal line. So this is horizontal. Anytime you get a 0 in the denominator, that tells you that we have an undefined slope. Undefined. Okay, and an undefined slope is a vertical line. Okay, so horizontal and vertical lines are perpendicular. So at this point I can say that I'm definitely working with a rhombus. Okay, and I don't even have to check a rectangle, because if you think about a rectangle and you check about their diagonals, okay, diagonals on a rhombus are not, or excuse me, diagonals on a rectangle are not perpendicular. So if you wanted to write down that fact for a rectangle, the diagonals are congruent and are not perpendicular. Okay, so those are some facts about proving or disproving those two pieces. All right. Okay, moving on to number 9. For what value of x and y is the figure a square? So we have the parallelogram given. We know parallelograms diagonals bisect each other. So we're giving an SU, so that full length there, and a TV, and an angle SWV. So they say specifically a square. So if we are working with a square and we're talking about diagonals, okay, here's another fact. We're working with a square, diagonals are congruent, okay, and because all 4 sides are the same, they're also going to be perpendicular. Okay, so this angle that they're talking about, this SWV, is a perpendicular or a 90-degree angle. Okay, so for me to solve these 2 equations, I'm going to say my 2 diagonals are going to be equal. So algebraically, I'm going to set the 2x plus 18 equal to the 6x minus 30 and just solve that equation. So I'm going to start by getting my x's on the same side. I like to keep positive amounts of x's, so I'm going to subtract my x, my 2 x's. Then I'm going to add my 30 over. I'm going to run out of space here. So 30 plus 18 is 48. And if you divide that by 4, you get an x value of 12. So there's your x. Let's see. So now working with the y, since that is a 90-degree angle, I'm going to set that equation equal to 90 and solve it. So I'll subtract 6. That makes 84. And if you divide 84 by 2, you get 42. There you go. So, if STUV is a square, what is the perimeter? Ooh, that is an interesting question. Okay, so let's draw this out. So we have the diagonals. So let's find the length of one of these diagonals, and then we can break this down. So if the diagonal, if the x value is 12, let's go back to TV, and plug 12 in, we can find the length of the diagonal. So that makes 24 plus 18, so 42. So the diagonal length is 42. Okay, so what I need to do here is find the side lengths of my square. So hopefully what you noticed here is that I've cut this into a triangle, and not only a triangle, but a right triangle with 2 side lengths that are the same. Okay, so for me to find this and solve this triangle, I can use a Pythagorean theorem. Okay, so Pythagorean's theorem is a squared plus b squared equals c squared. So I'm going to set that up as s squared plus s squared equals 42 squared. So s squared plus x squared makes 2 s squareds here. I'm going to go ahead and square 42, and 42 squared is 1,764. So now we would divide by 2. So if I divide that by 2, I would get 882. And my last step here would be to get rid of the square, so I square root it. So the square root of 882 is 29 point, I'm going to round that to 7. Okay, so if our side length is 29.7, I need to find the perimeter being all 4 sides. So my perimeter is going to be 4 side lengths. So if I plug 29.7 in, multiply that by 4, I get a side length of 118.8. Okay, and if I had units, I would label it, but there are no units. So there you go. Okay. Question number 11. So now we have this figure, and it starts out by saying find the perimeter. And it does say as an exact number. So let me show you how to find that as an exact number. It's actually a little bit easier than doing it with the decimal, because then you have to use your calculator. So I'm going to start by finding the side lengths of the obvious ones, like the straight ones. So A to B is 1, 2, 3, 4, 5, 6. A to F is 1, 2, 3, 4. From D to E is 1, 2, 3, 4, 5, 6, 7, 8. And I have 3 diagonals. So for me to find the distance from those diagonals, I'll start here. So from E to F, I have to do a distance formula. So distance formula is the square root of, let's see, we got to find this point. So this is going to be 1, -4, and E is 3, -6. So we're going to do our change in x's. So 3 minus 1 squared plus our change in y's. So -6 minus -4. That makes plus. And we end up with 3 minus 1 is 2. 2 squared is 4. -6 plus 4 is 2. -2 squared is 4. So we get a square root of 8. Okay. So there's your E to F length. F. Okay, so now we're going to do C to D. So C is 1, 5. D is 3, 2. So from C to D, our difference in x's, so 3 minus 1. Difference in y's is 2 minus 5. So 3 minus 1 is 2. 2 squared is 4. 2 minus 5 is -3. -3 squared is 9. And 4 plus 9 makes 13. So we'll leave that there. So that's your CD. I'll do the last one in blue here so we can tell the difference of my work. So going from C to B, the B point is -3, 2. So we'll call B, C. So difference in x's, so we have -3 minus 1. And 2 minus 5 for your y's. So -3 minus 1 is -4. -4 squared makes 16. 2 minus 5 is -3. -3 squared is 9. And 16 plus 9 is 25. Ooh, we get a perfect squared. Square root of 25 is 5. So that one has a solid length. Okay, so to find the perimeter here, I'm just going to add all this together. So I'm going to have 6 plus 4 plus the square root of 8 plus 8 plus the square root of 13 plus 5. So that's all of our sides. So now I'm just going to add my like terms. So like terms are going to be the constant values. So 4 plus 6 is 10. 10 plus 8 is 18. 18 plus 5 is 23. So we'll have 23. And then my two radicals are their own term. You just can't add them together. So you just leave them as those. So then you just circle your answer. That's kind of a nice answer. Okay, all right, and number 12 is now finding the area. Okay, I'm running out of colors here. Let's see, let's use, I need like a purple or something. Let's do purple, perfect. Okay, so the area, I'm going to cut this down into shapes. So I see a big giant, looks like a square to me, and then two triangles. So the big square, let's double check, is 1, 2, 3, 4, 5, 6. So 6 by 1, 2, 3, 4, 5, 6. So it is a 6 by 6. So the big square is in fact 36. So now if we do the triangle up top, remember you have to have a height that's perpendicular to your base. So 1, 2, 3, 4, 5, 6. So this is a base of 6, height of 3. So 3 times 6 is 18, and half of 18 is 9. So area of a triangle is 1/2 base times height. And my last little triangle has a base of 2, a height of 2. 2 times 2 is 4, and half of 4 is 2. So the area of that one is 2. So if I add those three shapes together, I would have 36 plus 9 plus 2. 36 plus 9 is 45. 45 plus 2 makes 47. So we get 47 units squared on that. All right, almost done here. All right, so question number 13. We have a triangle. The H to J is a mid-segment, meaning the H is the middle of G and I, and J is the middle of F and I. So we have to start by finding the coordinates of J and H. So I'm going to start with J because that's the easy one. So we're looking at the middle between F and J. So to find a midpoint, you add up the two x's and divide by 2. So let's see, I'm going to write this right here. So for J, my two x's is going to be 0 plus 2a and divide by 2. So if I do that, let's see, I'll just kind of write this over here. So 0 plus 2a is 2a, and 2a divided by 2 is a. For my y's, I have 0 and 0, so 0 plus 0 is 0, and 0 divided by 2 is 0. Okay, then I can find my h, doing the same idea. So h, we're going to add the two x's, so I have 2b plus 2a divided by 2, and if I simplify that, I can divide everything by 2, so the 2's all cancel and I'm left with b plus a. Interesting. Okay, my y's, I have 2c plus 0, so 2c plus 0 is 2c, and 2c divided by 2 is c. So that's your h point. Okay, so now question number 14 is we're going to use geometry to show that HG is half of IJ. Okay, so we're going to do that by the distance formula because we're talking about a distance. So I'm going to do let's see, we'll do the distance of HG. So distance of H to G right here. So distance is HG. Okay, so we're looking at this one to this one. So we're going to find the difference in x's. So we're going to have b plus a minus 2b squared. And then we're going to do the difference in the y. So c minus 2c. c minus 2c squared, okay. So let's simplify this. So on the inside here, I technically have b's that I can combine. So b minus 2b is a negative b, so I have a minus b. And c minus 2c is a negative c, and negative c squared is positive, right? Negative times a negative is a positive, so c squared. Okay, so hg is this distance. Okay, so if we wanted to find ig, we can just multiply that by 2. So ig, from I to g, we could just say 2 of those distances we just found. So I'm like just literally copying that down. So this is hg, and this is ig. G. Okay, all right, last one. So we are working with a parallelogram. So we have this PQRS is a parallelogram, and then it says that QU is congruent to ST. And we're going to prove that PU is congruent to RT. Okay, so anytime you're given a proof, you always start what is given. So you can say PQRS is a parallelogram. And the reason is given. Okay, and you can say that QU is congruent to ST because it's given. Okay, so for us to prove that PU, so that leg versus RT is congruent, what I'm going to do is I'm going to kind of break this into like the idea of triangles. So if you can kind of see this one versus this one, we're trying to prove first that those two triangles are congruent. So for me to do that, I need to say that PQ is congruent to SR. And we can say that because PQ is congruent to RS, because since we're working with a parallelogram, opposite sides are congruent. So I can say opposite sides are congruent. The parallelogram. Okay, so now I can also say that the angles that are opposite, so Q and S, so I can say angle, and to be very specific, I want angle PQU to be congruent to angle RST, and I can say that basically the same as the above statement, only opposite angles are congruent in a parallelogram. Okay, so now if you look at this, I have two triangles, and I have a side, angle, side, side, angle, side. So now I can say the two triangles are congruent. So I can now say that triangle PQU is congruent to triangle RST by side, angle, side. And now, because those two triangles are the same, I can now say, let's see, green, that these two lengths are the same. Okay, so now I can say that PU is congruent to RT because corresponding parts of corresponding parts CP of congruent triangles are congruent. Sorry, I screwed that up. Okay, so there is the proof on that one. You might write that down. Okay, so at this time, make sure that you turn this review in. So if you did do it on Cami, you turn it in. It just should be at the top right-hand part of your screen. If you have a paper version, turn that in, and it is time to take your test. Good luck.